In this video, we're going to look at another example of using use substitution to evaluate an integral. So what part 1 of this problem tells us is we're going to use the substitution u equals x to the 6th power to rewrite the indefinite integral, and then we're going to evaluate it in terms of u. Okay? Seems simple enough. So they've given us our u to use as our u substitution, right? So let's go ahead and figure out what our du is going to be. So u is a function of x, x to the 6th, but then if we use the definition of the differential again, we get that du equals the derivative of this function of x, which is 6x to the 5th, and then times dx, right? So we have 6x to the 5th dx right here. So let's see how that looks as like making these substitutions of u into our original integral goes. Okay, so here we have x to the 6th is inside of our argument of our trig function, and then we also have components of our du, namely x to the 5th and dx, sitting right there, right? Well, then where does this 6 go right here? Well, just like we saw in last video for the first problem of this section, we can divide it away to take it to both sides to say that du over 6, or 1/6 du, equals x to the 5th dx, right? So whenever we plug in our thing in terms of u for x to the 5th dx, we're going to plug in 1/6 times du. Okay, so what does our integral look like? Well, we're going to have the integral of cosine of u times 1/6 du, or, which is going to turn into the integral 1/6 cosine of u du, like this, right? Multiplication is commutative, right? So the order of the multiplication doesn't matter. So we can put 1/6 in front of cosine of u. We can put it right here. I just like writing it like this so that we have our constant multiples in front of our function, and then we have our differential right there. Just kind of, it looks nice. It's easy on the eyes like that. Well, why did we pick this substitution u equals x to the 6th other than the fact that it was given to us in the problem? Well, the unique thing that we see about x to the 6th is that it's the argument of a trig function, right? So what we can do is, instead of integrating cosine of x to the 6th, because we don't really have a chain rule or a way to deal with composite functions in terms of integration, because it gets kind of messy, what we can do is we normally like to try to pick things like this: arguments of trig functions, powers of exponentials, arguments of log functions, just kind of the inner functions of compositions of functions. We try to use those as our u to make our substitution, and try to make everything else work for us kind of going forward, right? And we saw that it naturally took care of this x to the 5th out front by taking the derivative of what we had here, right? So it all worked out kind of nicely for us using x to the 6th as our u, because then we found du to be this, and it all kind of fit together like a nice little puzzle piece, right? So now we're left with the integral of 1/6 cosine of u du. Well, now what this turns into is an integration problem of this function with respect to u. Okay, so let's go ahead and integrate this thing. This 1/6 is a constant multiple, right? So we can write this as 1/6 times the integral of the cosine of u du. Well, then what is the integral of cosine? Let's think about that. We know that the derivative of sine is cosine, right? Well, then if we take the antiderivative of cosine, we're going to get back to original sine, right? So what this tells us is that we're going to have 1/6 times the antiderivative of cosine of u is sine of u, and then, since we're dealing with an indefinite integral, we're going to tack on that arbitrary constant of integration, right? That plus c right there. So then if we distribute 1/6 back into this, we're going to get 1/6 sine of u times also, or plus 1/6 times c right here. Well, then if we multiply a constant times a constant, what are we going to get but just another constant, right? So it's still going to be plus c, and this is what we're going to get as the evaluation of our indefinite integral in terms of u is going to be this thing here. So now we've done the first part of the question, right? We evaluated the integral that we rewrote in terms of u, did all that stuff, and we got that, and we're fine and dandy. Well, now the last part of u substitution is, in this case, dealing with indefinite integrals specifically. We need to take care of part 2 and what it tells us. And it tells us to substitute back into the antiderivative above using like our functions in terms of x again, right? Because the original question that we were given was in terms of x. So if we write down an answer in terms of u, it's going to lead to some confusion as to, okay, well, we asked you a question in terms of x, how'd you get an answer in terms of u? It's just kind of one of those things we got to make a substitution back to make sure that we're actually giving an answer in terms of what we originally asked to integrate with respect to. So essentially what we need to do is plug back in our functions in terms of x that we allocated as u. Does that make sense? So essentially what we're going to do is we're going to have our thing that we wrote in terms of u, plus c was our evaluation of our indefinite integral, right? But then using the fact that u is x to the sixth, how we're going to write this is 1/6 sine of x to the sixth plus c, and this is going to be our antiderivative with respect to x, which is what we were originally asked in this question, right? We were originally asked to evaluate the integral x to the fifth cosine of x to the sixth dx, but since we can't really evaluate this straight away, because this is the product of a composite this is the product of two functions where one of them is a composite function, what we wanted to do was instead rewrite this in terms of u to be able to integrate it more simply, and then make this substitution back to give us our antiderivative in terms of x, which is what we started with. Does that kind of make sense? So when we're dealing with indefinite integrals, we got to make sure that our antiderivative is going to be in the same terms of the integrand that we started with. Okay? When we look at definite integrals, which is going to be the next couple of videos, we can see that we can use a trick that can kind of leapfrog this step in a sense. Because when we make substitutions with this u here as functions of x, we can also evaluate our bounds of integration in terms of u to kind of change the whole problem into an integration in terms of u that's going to give us an like by using the evaluation theorem, is going to give us an answer that would be the same as if we were to do this substitution and leave our bounds alone. Okay, I know it sounds kind of confusing and out there, and he just explained all this stuff. He didn't write anything. What the heck's going on? But if we hold on for the next video that we're going to have inside of the section where we do substitution with definite integrals, I'll kind of try to explain it a little bit more coherently, and hopefully it'll make a little bit more sense. But for the time being, dealing with indefinite integrals, we do have to make the switch back to have our answer in terms of x like this.